All right, we're going to talk about biconditionals and definitions. So a biconditional is a single true statement that combines a true conditional and its true converse. If you can write a biconditional by joining the two parts of each conditional with the phrase if and only if. This is kind of like a shorthand method, the IFF, that stands for if and only if. You'll see me, a lot of times I'll write it all out like this. If I'm writing out a sentence, I'll shorthand it if we're trying to do some work. Okay. Write the biconditional of the conditional. Okay. So the sum of the measures of two angles is 180. Then the two angles are supplementary. So if I look at this, is this a true statement? If the sum of the measures of two angles is 180, then the two angles are supplementary. Yes, that's true. I now have to look at the converse. If two angles are supplementary, so I'm moving this to the front, then the sum of the measures of two angles is 180. Is that true? Yes. So now that I know that the conditional and its converse are both true, I can write this as a biconditional. Okay? And I'm going to write it as the sum of the measures of two angles is 180 if and only if the two angles are supplementary. And I could have flipped it around. Two angles are supplementary if and only if the sum of the measures of the two angles is 180. Okay? So you're basically taking out the if then and putting in if and only if right in the middle there. A biconditional combines if P then Q and Q then P as P if and only if Q. Okay. What are the two conditional statements that form this biconditional? So here's my biconditional. A ray is an angle bisector if and only if it divides an angle into two congruent angles. So I'm going to split this biconditional into two conditional statements. Okay? So the first one is I'm going to put an if at the beginning. I'm going to replace it, the if and only if with a then. If a ray is an angle bisector, then it divides an angle into two congruent angles. That's my first one. So I'm just putting an if at the beginning, pulling this out, putting it then. Now I'm going to flip the order. I'm going to put an if here. So I have this word it, and what is it referring to? Ray, so I'm going to put here. If a ray divides an angle into two congruent angles, then it is an angle bisector. Okay? Writing a definition as a biconditional. So here's our definition. A quadrilateral is a polygon with four sides. Okay? So a quadrilateral is a polygon with four sides. So if I read this, if it is a quadrilateral, then it is a polygon with four sides. If I read it the other way, if it is a polygon with four sides, then it is a quadrilateral. If that's true, then I'm going to write the biconditional. Okay? So I'll write this one out. A figure is a quadrilateral. Okay, so I did have to add a figure. That's fine. If and only if, and I could probably say a polygon is a quadrilateral. We could change that. Maybe I should put polygon. If it is a polygon with four sides. Okay? So there's my biconditional. Okay? We also have to kind of identify good definitions here. So sometimes this is a little bit harder than we think. We think that we have good definitions, and we actually might not be strong enough, or we might be too strong. So which of the following definitions is a good definition? A fish is an animal that swims. Okay, is that a good definition of what a fish is? Rectangles have 4 corners. Is that what a rectangle is? Giraffes are animals with very long necks. A penny is a coin worth 1 cent. Which one of these is the best definition or a good definition? Well, are there other animals that swim? Yes, fish aren't the only animals that swim, so this probably isn't a great definition. Are there rectangles have 4 corners? Well, that's true, but what makes a rectangle? Just 4 corners? Well, that's actually a quadrilateral. Rectangles are very specific. All 4 angles have to be right angles. Giraffes are animals with very long necks. Well, what's your definition of very long? D is probably, our best definition is probably a good definition. Penny is a coin worth 1 cent. Why did the man sleep with a ruler? Well, he wanted to see how long he could sleep. What has wings and solves number problems? A mathematician. All right, so that's biconditionals. Remember, you're putting that biconditional in a hypothesis, if and only if, conclusion, or vice versa, because they both are true.